Hi everyone, welcome to Geek Coding Academy. Today we'll see Collection Framework Chapter 6.10, that is generics and its uses in a collection framework. So in our previous video, we covered all of these topics, and also in our very previous video, we talked about on concurrent collections. So if you have not watched that videos, please watch that videos prior to this. So today we'll see on what is generics and what is uses in collection framework. Okay, let's start. Generics and the collection framework. So first of all, what do you mean by generics? Okay. So in Java, especially, like after Java 5 version, a special feature has introduced called as a generics. Okay. So what is generics is, uh, it is we can able to create a classes, methods, and interfaces that operate on parameterized types. Means like we can able to create a classes, methods, and interfaces such that that's not bound to a particular type. It will be bound to like at the time of creation we can define a types, means type of data which it will hold. Okay, so I'll explain you with more in detail. So what is the use for this is, these allows a developer to write a flexible code. Okay, these allow for us to write a flexible and reusable type safe code. Okay, it brings two primary advantage. One is type safety, means at the time of compiling only we can able to come to know that what type of data we are going to store in here. So during runtime we don't find any surprises of any errors. Okay, and also elimination of a cache. That means like suppose if other type of data was stored in this collection or in this using these types, and we want to retrieve, we need to explicitly tell the compiler or tell the Java to cast it to our types that are not required if you use generics. Okay, so I hope you guys like you guys are little bit confused. Let's see from the example point of view so that you'll get more understanding. So first of all, why to use generics? Okay, so before generics, what happened? Like in collections, in collection framework, the data we are storing, it was considering as a raw object. Okay, so that means like for example, if I define a list, I can able to store string also, and I can able to store uh, another type of data also, like integer also. So at the time of retrieval, what happened, like suppose I was trying to retrieve a string data. At the time, if in middle, if I get any integer type of data, I'll get any runtime exception, like a class cast exception. So what Java people thought is, or what they have decided is Java team. So in after Java 5 release, they've introduced this generics. Why? Because at the time of writing a code itself, we can able to define properly like what type of data we are storing. Okay, and such that only those type of data will save into this collection. So at the time of compile itself, we can able to set a rules such that at runtime we don't see any surprises like a class cast exception. Okay, so here in the example you can see before generics we have initialized a list, an array list which is of type list, but here we are not defined anything like what type of data we are storing. Okay, before Java 5 I'm talking. So I was adding list dot add allo. Here I'm string data I'm adding to this array list. And then also I can able to add another type of data also. Suppose like list dot add 10. So it will add because that time like a collection concept is for storing in a data which is of raw type. Means any type data it will store. That's the concept. So after that, while retrieving, the problem is while retrieving, when I try to retrieve the data from this list, suppose list start get of 0 means first element I'm retrieving. I want to retrieve it in a string because I stored allow here. So what happened? Manually I need to cache that raw type into a string type using this type casting. Okay, this are all works fine unless until only similar type of data will stored in this array list. Suppose if any other type stored means suppose like a 10 numeric type of data or any other type of data stored inside this array list means at this point we'll get a class cast exception because we are trying to cast it to string, but the type of data we are providing is different type means we'll get a class cast exception. In order to avoid that, a generic concept was introduced. Means it was like we need to provide clear definition, like what type of data we're going to store. Okay. So let's see with an a generics example. Like after generic was introduced, what it is list was trying to create an array list which is of type list, and also I need to define here what type of data I'm storing here, string. So list dot add allow, it will accept. If I write a list dot add of 10, at the time of writing data, at the time of writing a program, like compiler will only tell this type of data is not allowed here. And also while retrieving, I don't need to explicitly um, give a typecast. I don't want to typecast it because I already maintained here the type of data which I'm going to insert. So only string type of data I can able to insert into this array list. So while getting, I don't have to write explicitly typecasting. So what do you mean by generic classes? Okay, this was what we saw is generics, which we used in the collections classes. Similarly, like our own classes, if you want to define, I could use generic. Okay, a generic class is a class that can work with any specified at the instantiation. The type of like the type is specified by the type parameters enclosed with an angle brackets. Okay, so means suppose I have a class called box where I am doing some logic. I return some methods up here, and these methods require a specific type of data. Okay, so instead of writing it here in this class level itself, instead of writing, suppose sometimes I need a string type of data. Instead of making this private element as string, or sometimes I need an integer type of data. Instead of making it as an integer, so that I can make it as a generic type like t. These brackets, these angle brackets inside, we need to define a type, right? So instead of that, I can make it as a t. That means it's a generic class. That means at the time of initializing this class, at the time of creating a object for this class, it's a programmer duty to define what type it is. Okay. In this example, we can see, so box is my class. I'm just trying to create a new of box, but at the time of this creation, I'm passing here is in the angle brackets, I'm passing here a string. That means like I'm creating this object, I'm going to pass a string type of data. So this is the reference variable string box dot set item allow. When I print this get item, I'm getting an allow. Suppose in my second scenario where I need to store some integer data. So box of new box, which is like I created the same object, but at the time of creating an object, I defined here as an integer. Okay. The int box set item is equal to 1, 2, 3. When I print it, I am getting a 1, 2, 3. So here reusability, code reusability will be increased, right? So sometimes I can able to pass a string and sometimes I can able to pass integer data. So at the time of creation, I can able to define the type of data which I'm going to store up here. So this is one of the example of generic which will be used for classes. Okay. So multiple type parameters means like only one. It's not necessary that only one of the type we need to define. We can define multiple types also. That means, for example, if you're using some hash map related, we have a key value pairs, right? So in that cases, both key and value have some types. So such that suppose I'm returning one class pair where it requires two data. Individual two datas can have a different types. Suppose here last time I taken it as a t, right? Like now I can take it as an k and v, some value. Where k is the key and v is the value. I'm just return some method over here and some getters over here. So at the time of creation of this new pair, it's developer duty to define like what is the type of data. So it is a order. It takes the orders. Like that means like first I return string means k value, the key will go will take string, and next I return integer means the value will take as an integer. Okay. When I print this key and value, I get the same age and 30. Okay, because at the time of creating an object, I'm passing these values age and 30. That means I'm calling in a parameterized constructor here. Okay. So these generics is not only limited to classes, it also we can able to define in methods also. Even though the class level we didn't define, at a method level we can define the types. Okay, a method can also declared as a generic, even if it's the class containing it does not have any generic, but the method can have any generic. Suppose like I have returned a one method here, print array under any class. So where it requires some array, and I don't want to stick to particular type. I want it to be generic. So I can make it as a T array. T means like generic. At the time of calling this method, I could have passed the type of data, what I'm going to pass. And return type is also, I can make it as an a T. Here I'm written a for each loop inside this method where element which is of type T and the array which I'm iterating, this is a for each loop where I'm printing an element here. So at the time of usage, you can see here, first time I created was integer array, int array 1, 2, 3, 4, 5, and string array, that is string array ABC. I'm calling this method and I'm passing this int array. Next time I'm passing this string array. So this int array is of type integer array. So here I'm not bound to any specific type. I just made it as a generic, right? So first time it will act as an integer array, and what it will return is what it will print is the elements. So it will print 1, 2, 3, 4, 5. Second time I made it as a string array, so it will return the ABC. So this is the use of this is will be like we can able to use the method, right, for multiple type of data. Okay, bounded type parameters. Bounded means suppose like till now we discussed about the types which we has to define at the time of creation of classes or at the time of calling a method, or if you write any collections, um, we have to define specific type. But what happens if I want a range of types? Okay, suppose I want to store a data such that it will be like a child of all these parent class. Suppose a parent class is a 10 child classes. So I just want to declare a collection or any method such that it will accept only the child classes of this parent. Here I'm defining a range of types, right? I'm not pointing to any single type. So these were called bounded types. Okay, generic types can be bounded to enforce constraint. These allow us to limit the types that can use with the generics. Okay, there are two types: upper bound and lower bound. Okay, let's see what is an upper bound. So upper bound means we are limiting the what type of data such that suppose like we need to use an extend keyword to set an upper bound for the generic type. These ensure that the type of parameters is either specified type or its subtype. That means here you can see in the example I have defined here a method which is of which it will be returned void and public. So here I'm just defining the type of data it needs. The T is the type of data it needs, and also extends number. Okay. So either you can pass a number, it's a parent class, number type of data, or it's child classes. Like integer is a child class of number, atomic integer is a child class of number, float is a child class of number, double is a child class of number. All these values, if you pass, it will accept. So this is what called a upper bound, means we are defining in a parent here. All child will be accepted here. So this is called as an upper bound, where I'm just printing value, number dot double value. Here you can see here, first time I pass the integer value 10. Next time I'm passing in a double value here, 10.5. Okay. So what do you mean by lower bound? So lower bound means we'll define ultimately like base level child. So such that our class or our method will accept this child type of data and also its parents. Okay. Whatever parents this child belongs. Okay. Like this child belongs to which parent? Sorry. Like we can use for this is a super keyword to specify a lower bound of type. Suppose like public static of void add numbers, I'm just creating an add numbers where it will accept list, but the what type of list it will accept is question mark super of integer. What is this question mark? This is a wild card, I will talk next. Question mark super of integer means it will accept integer at the lowest level, lower bound. On top of it can accept its parent type, that is number type also it will accept. where I'm just adding here 10 and 20. So here I'm creating an array list which is of type list of numbers. It's a parent type. And I'm calling in a method called an add numbers of numbers. Here I'm passing list of numbers. But while defining, I defined here super integer. Means child is integer. So it can have a parent with this number also. Like number is the parent and integer is a child. So this is what called lower bound. So we'll define a child's type and the method or class where we define like this will accept its parent type. Whereas an upper bound will define the parent level. So all child classes which are related to this parent will be taken into consideration. Wildcards, we already saw in our lower bound that super of integer we created, right? Here, super of integer, where we defined here in a question mark. This is what called a wildcards. So the wildcards is used where the exact type is not known. Okay, we don't know the exact type. As you can see here, we don't know the exact type. When you want to work with a range of types, we often go with this wildcard. Okay, these are often used in method parameters. Okay, what is wildcard is there are three types of wildcards. One is unbounded wildcard, means represent any type. If you put a question mark, it will act like a wow, the Java collection will be there, like before Java 5, when before introducing these generics. So it will accept all the types, right? So it will become like that if you put a question mark. It will accept all the types, integer, string, everything. That is one type. Second type is upper bounded wildcard. Means if you put a question mark, extents of t, that represents it's a sub. It will our method or our method will accept a value which is of t type and its subtype subclasses. That is what called an upper bounded wildcard. Lower bounded wildcard means the question mark super of t, which represent any type that is superclass of this t. Means we are representing in lower bound wildcard. We are saying here um, our data is of this child type, and also it may be its parent type also. Okay. Let's see in example. Unbounded wildcards means suppose like our a method we have a method called print list which accepts a list data where list in the brackets in the angle bracket we put it as a question mark. That means it will accept a list type of data, but I am not sure about the type of data which it going to add. So I put a wildcard. This will behave exactly similar like how before Java 5, means how before generics. Because the time we have a saving data, all type of data into a collection, it will act like this. Upper bounded wildcards. Here some limitations will provide like list where question mark extends a number which of type list means I'm passing a list which should be number, number type or its subclasses type. Subclasses number will be like integer, it may be integer, it may be float, it may be double, it may be atomic integer, etc. Atomic int, etc. And the third type is lower bounded wildcard, where I defined like this list question mark super of an integer. That means my method will accept integer type of data and its superclass. That is integer superclass is number type of data also. Okay. Sometimes like an add list out of add 10 and list out of 20. Okay. Okay. Now let's come to the concept called type erasure. Yeah, type erasure means like whatever type we are defining here in this collection or in our classes level, that's only at the compile time only. Because at runtime, it will remove all these types. It will behave like how it was previously, the Java. That's what it is. Like Java is just type erasure to implement generics. That means at runtime, the type information of the generics will be removed. This ensures backward compatibility with the earlier version of Java. Pre-generics, like pre-generics Java, and now whatever we are using Java, it should be compatible, right? So what it will do is like at the compile time only we can able to have these type of generics we define. Once it's compiled and once its code is running into a runtime environment, it will remove these generics. Okay. So what is the use for is this compile time checking. The generic type parameters checked at the compile time. Type whatever type information we provided, it will be removed. So after compilation, generic type information is replaced by raw types. That's what our previous Java is supporting. Raw type, such that object. So like such as it will make an object or a bounded type. For example, see here in a compile time, I created one array list which is of type list of string, and I created one more array which is of type list of integer. At runtime, both string list and int list become list of object. Okay. The runtime, once it's compiled, there is no question of it's a list of string only, it's list of integer only. Both will become list of object. That is a raw type only. But why we need these generics is at the time of compile time itself, we can able to see what type of data we are putting in. We don't want unwanted surprises. Okay. This is why we can't check generics types at the runtime. Suppose like how we can able to find out is, suppose in runtime we are running string list is an instance of list of string. List of string we created, right? Like if you make it string list is a instance of list of string, we'll get a compile time error because there is no question of generics at a runtime. So what's the limitation of generics? First of all, we can't use a primitive data types. Primitive data type means int, char, float, all of these primitive data type because these data types we can't use inside of a generics. Okay. Suppose like a list of int is equal to new array list, we can't able to do. We need to use is wrapper classes, integer, character, etc. Why? Because at the time of runtime, it will become an object only, right? So we can't use these primitive data types. Okay. We need to use a wrapper classes only because wrapper classes is a subclass of these objects. No generic array creation. And also for array concept, this will not support. We can't directly create a generic arrays. Like how we create for generic collections. We can't create a generic array or array of new T of 10 we can't provide. Up to at least this time. Don't know in maybe in future they may introduce or not, but it's not required, right? Because array will allocate some amount of memory. For int means it will allocate some integer required memory. So that's the reason like for array concept, maybe we don't have any generic concepts. Okay. And not only, I already told generic is not only for classes or methods, for interfaces also we can use. Similarly, I created one interface which is of type T. In angle brackets, I make it as a type T, where I'm two getters and setters, set and get, both are type T. At the time of implementing class, like the child class which is implementing this container has to provide the type. It's that child class duty where string and in a new item got created, and both this set and get will take this item which is of type string. In this case, suppose if another child class which is implementing this container which is of type int type, then it will change accordingly this type. Okay, the type interface with the diamond operators. Like what is diamond operator in Java 7 onwards? Something as some modification they did for this generics is using a diamond operator. Why? Because initially in the previous version we have to write like list, and we in angle bracket we need to define string means it is a type, and the reference variable is list equal to new array list. Here also we need to provide string type, but that's unnecessary, right? Like new array list, I'm passing here that empty diamond operator closing because this we catching will be like list which is of type list of string. Already we defined list of string means this array list will store a string type of value. Again we need to define here in this angle brackets also. That's not required. So what happened is after Java 7 they introduced the diamond operator means angle brackets without defining anything. So that will be reduce the necessary writing of again type. So we can able to write like this. That's a simple concept. Subtyping and generics. So in Java, by default, it will not support covariance and contravariance directly. That means I'll tell you. Suppose I in Java, suppose like I have a animal class. The child class of animal class will be dog class and cat class. Both are belong to animal. Okay. Even though dog is a subtype of animal and cat is also subtype of animal. Suppose I've created a list of animals, one list with animal. I can't store both dog and cat into it because it's not right? Because dog and cat are something totally different, even though they are animals. So that's how the prevention of adding incompatible objects, like adding a cat to list of dog. Okay. So this is what I'm declaring here. So I created a dog here, new array list, which is of type list of dog. And list of animal can't catch this dog object. Why? Because even though it's a parent, it will not support these covariance and contravariance directly because it will get a complementary error. In order to don't want to mix the data, by default it will not support, but we can able to make it support. That's the reason we have that wild card, lower bound, sub bound, and everything. So how we can able to make it allow covariant and contravariant behaviors is, suppose we want to store dog inside of these animal references, I can make this animal reference as list of wild card. Means I don't know the type, which extends animal. Means anything which comes for animal level type, that's okay. And also is subclass level. Okay, this is some type like an upper bound wildcard entry. So guys, these are all about generics. So this generics is used for programmer make the code reusable and make it more efficient, such that we don't want to find any unexpected events happening at runtime like class cast exception. And Java is a highly typed programming language, means everything, each and everything need to be checked properly. So the generic supports make it Java more type specific. And using generic, we can use a wildcard, means we can make it to previous how we are using like raw types also. And generics in Java enable us to write a flexible, reusable, and type safe code, understanding their use and including bounds, suppose like upper bound and lower bound we discussed, and wildcards, and type erasure like means unnecessary writing two times types not required, and subtyping. Subtyping means like if it's a child class, automatically the parent list can't able to collect this child list unless and until we need to provide the wildcard entry. So it's essential make these are all required to make our Java into a more type specific and prevent unnecessary exception at the runtime. So guys, this is all about today's lecture. I hope you guys have understand the complete generics concept in collection framework and totally generics. So in my next class, I'll come up with a more advanced concepts. So thank you for watching. So till I'll meet you guys in my next lecture. Till then, keep watching, keep learning. Thank you. Bye.